1.6 making decisions and predictions. I can use probability to make decisions and predictions.
Yes, no?
Yes.
Awesome. Okay, so what we did is we used ratios and proportions to make a decision and or a prediction here. We had customers at Target in Eden Prairie. 500 of them, in fact. They walked out of the store and someone asked them what they thought. 125 said, oh, I was really happy, I was pleased. 340 said that was an average experience. And 35 said, I am mad at Target. Target took that information and they said, all right, if we ask 500,000 people, because that's about how many people go through our stores each day, how many people would be mad at us? Because they didn't ask every single store to do this, they just asked Eden Prairie. And so they took Eden Prairie's data and they had 35 out of 500 unhappy, right?
Yeah.
And they lined up their labels. If this is 500 total, and we want to know how many people would be unhappy out of 500,000, we're going to put 500,000 on the same line as 500. How do you get from 500 to 500,000?
Multiply by.
So if we multiply 35 unhappy people by 1,000, how many unhappy customers does Target have?
35,000.
Whoa, that's a lot of unhappy customers, right? So they're going to probably want to do something about that. That's good data to have. Number 2, Sam. He wants to know how many times he's going to draw the 6 of clubs if he does it 1,000 times. So he has a deck of cards. He draws a random card 1,000 times. And he wants to know how many of those times is he going to get a 6 of clubs. On a deck of cards, there are 52 total, right?
Yeah.
How many times do you draw the 6 of clubs?
1.
Once. So if he's going to do this 1,000 times, or draw 1,000 cards to line up our labels, cards and cards, right? How do you get from 52 to 1,000? Multiply by 19.23, right?
Yes.
And if you multiply that, and that's a rounded number, if you multiply that by 19.23, we figured out that Sam was going to get a 6 of clubs about 19 times out of 1,000. Yes, no?
Yeah.
Okay. And then the fair game. Helen and Maya each flip a coin. Helen wins if exactly one coin lands heads. If not, Maya wins. Prove whether or not this is a fair game. Here's our proof. I know we just did this, but I'm going to remind you tomorrow when you're watching this video that you guys all thought that the game was not fair, right?
Yeah.
And if you look at it, it looks like Maya wins twice and Helen wins twice, right? Therefore, the game would be fair. You all thought it was not fair because you forgot or you did not forget. You just did not do what? You did not draw your proof. You did not draw a tree diagram. Is it important that you do so?
Yes.
Obviously it is. And then we changed the rules down here because Maya's the sore loser, right, Maya?
Yep.
She changed the rules, and this time you all drew a tree diagram, and you all realized that because Maya changed the rules, she's going to win 3 out of every 4 times. So it's not a fair game then, is it? Questions?